So there is no number that when squared makes 27. So I can't immediately just write down an answer here, but I can simplify this. We can do something. Because even though 27 isn't a perfect square, it actually has a factor that is a perfect square. You see, 27 is 9 times 3. And because of that property that we had, we know that this is the square root of 9 times the square root of 3. And the square root of 9 is 3. So this is just 3 root 3. So you see what I did here is I pulled out a perfect square factor. Perfect means that when you take the square root, you get a whole number. And so it's a perfect square. It's a whole number squared. So I pulled out a perfect square factor, and then that I was able to, because it's a perfect square, I can take the square root. So that enabled me to simplify this. So let's do another one. Let's do the square root of 80. Well, I have to find a perfect square factor. Well, 80 is divisible by, let's see, what's the largest perfect square factor I can think of? 16. That's maybe not immediately obvious, but it's 16. 80 is 16 times 5. Now, even if it's not obvious, I'll show you a kind of a trick to do if you can't find it right away, all right? So that means I can write this as square root of 16 times the square root of 5. And the square root of 16, well, 16 is 4 squared, so the square root of 16 is 4. So there, I've simplified root 80. I've pulled out that perfect square factor, and I'm able to take its square root, so it simplifies. Now, like I said, it may not be obvious that 80 was divisible by 16, but that's okay. You might find something else. Now, here I have to go get a piece of paper, so if you just excuse me for a couple seconds. So what if we couldn't come up with 16, right? Okay, so maybe I came up with some other perfect square factor, like 4. 80 is divisible by 4. It's 4 times 20. That's okay. This will get us there. It'll take a few more steps, but I can do the same thing. Square root of 4 is 2. So this is 2 root 20. But I'm not done. And we know I'm not done because I didn't get the same answer as before. Right? The answer is 4 root 5. I'm not there yet. So how do I know I'm not done? Well, because 20 has a perfect square factor. So I can keep going. I can go further. Right? Root 20 is, well, 20 is 4 times 5. So I can factor out another factor of 4. And so this is root 4 times root 5. And root 4 is 2. So this is 2 times 2 times root 5. And the 2 times 2 is 4 root 5. Okay, so that took a lot, that was a lot more steps than we did before, right? Before we just did bum, 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 3 steps and we got our answer. This took a little bit further, I mean, a little bit longer, but that's because we didn't catch that 16 was the largest perfect square factor. But it didn't matter. Even though we didn't find the largest perfect square factor, we're still able to, whittle our way down here and finally get to the end. So the idea is that if you can find the largest perfect square factor, which 16 was, then it'll be the quickest. Right? This process will be cut down and you'll have less to do. So you're always looking for the largest perfect square factor, but if you can't find it, it's okay. You can still get there. And we can do other roots as well. We could do something like the 4th root of 32. Something like this. So now we're looking for things that were raised to the 4th power. Ideally, I'd want to find something that when raised to the 4th power gives me 32. But when you think about it, you'll realize there is no such thing. Nothing raised to the 4th power gives me 32. But I do know that I know that 2 to the 4th power is 16. right? 2 times 2 times 2 times 2 is 16. And so, and 16 is a factor of 32. So what I'm going to do is I'm going to break this down as 16 times something. Well, 16 times 2 is 32. And I'll take the fourth root of 16 times the fourth root of 2. And like I said, 16 is 2 to the fourth. So the fourth root of 16 is 2. So that's how we simplify that one. So here, we're not looking for the largest perfect square. We're looking for the largest thing that is a power of 4, right? Not a power of 4, something raised to the fourth power, rather. So 16 is 2 to the fourth. So whatever your index is here, that's, you're looking for things raised to that power that are factors. So let's just do one more. Let's do the cubed root of 81. So now I want to find the largest factor of 81 that is a perfect cube, right? So something raised to the third power. Well, 27 is a perfect cube, and it's a factor of 81, right? 3 times 3 times 3 is 27. So 27 is 3 cubed. So it's a perfect cube. So let's factor that out. In fact, 81 is 27 times 3. What's the cube root of 27? It's 3. So I take the cube root of 27, get 3, and I'm left with the cube root of 3. So same as we did up here, except with cube roots instead of fourth roots. Now, if you're having trouble finding these numbers, 16, 27, what you can do is you can factor, how can I do this? Let's put this like this. You can factor your numbers, just start factoring them down as much as you can. So for instance, with the 32 up there, the 32, if I wanted to find this 16, the largest number raised to the fourth power, I'll just start factoring it. So I know it's divisible by 2 because it's even, right? So it's 2 times 16. And I know, let me write it like this. A lot of people write it like a tree. 32 factors as 2 times 16. And 16 is an even number, so it's divisible by 2. 2 times 8. And 8 is an even number, so it's divisible by 2. 2 times 4. And 4 is an even number. It's divisible by 2, so 2 times 2. So now I see that 32 is 2 times 2 times 2 times 2 times 2. And look, I got 4 of them right here. So that's 2 to the fourth. So when I break down 32, I know that I can write it as 2 to the fourth. Oh, I'm writing down here and it's off the screen. When I break down 32, I know I can write it as 2 to the fourth times 2. And then this part simplifies. The fourth root of 2 to the fourth is just 2. And let's do the same thing with the 81. If we had to do the cube root of 81 and we wanted to find that 27, so I'll take 81 and I'll start factoring it down. Well, 81 is divisible by 3. 3 times 27. 27 is divisible by 3. 3 times 9. And 9 is divisible by 3. 3 times 3. So look, I got 3 3s right here. So that's 3 cubed. So I know that cube root of 81 is 3 cubed times this number, 3. These won't always be the same number. I think just by chance I chose things that worked out that way. So the cubed root of 3 cubed is just 3, and then I'm left with the cubed root of 3 here. So you could just break down your number as much as possible, and that will get you to the answer as well. So let's just do one more. 40. So let's do the cubed root of 40. So what I'll do is I'll take 40 and I'll start breaking it down. So this is 2 times 20. 20 is 2 times 10. And 10 is 2 times 5. That's as far down as you can go. These are all prime numbers. That means they're numbers where you can't go any further. And look, I got 3 2s. So that means I know that 40 is 2 cubed, has 2 cubed as a factor. And what's left over here is a 5. So the cubed root of 2 cubed is 2. And then I have the cubed root of 5 next. So sometimes you're going to be able to spot the number. In this case, it was 8. 2 cubed is 8. You might just see that, oh, 40 is divisible by 8. So I'll just write that down. If you can't spot it, do this breaking down thing. You know, just keep factoring the number down until you see a number of factors equal to the index of the radical. Let's look at something like the square root of y to the 11. Okay. What we did before, what we did in the last section, is we found these numbers were divisible. This was divisible by that. So what I did is I wrote this number as something raised to the 3rd power, or I wrote this number as something raised to the 2nd power. Right? That's what I did here and here, and that enabled me to simplify it. Here, I can't do that. I can't write this as something to the 2nd power exactly, because 11 is not a multiple of 2. So what I'm going to do is the same idea that we did with the numbers. I'm going to find a factor that is a multiple of 2, that has an exponent that is a multiple of 2. So that's y to the 10. So I'm going to write this as y to the 10 times y. Why can I do that? Well, because the product rule for exponents says that when I multiply these, I add the exponents. So it's 1 plus 10 is 11. So I can always break it down this way. Or using the tree, what I've done is I've taken y to the 11 and written it as y times y to the 10. Same thing we're doing with the numbers. And now this is good because I can do this. There's that property we have. And the square root of y to the 10. Now that is the type of problem that we had over here, right? This number is divisible by 2, so that's what enabled me to do this. And so that's the same thing I can do here. 10 is divisible by 2, right? So when I take the square root, I end up just dividing by 2. So you can either write this as y to the 5th squared. I'll do it that way for this one problem. And then those cancel off. So I get y to the 5th times root y. Or a lot of times I'll just skip that step and just go right to here, knowing that when I take the square root of something, you divide this number by 2. What if I had the cubed root of y to the 11? Well, now I want to find a power whose exponent is divisible by 3. Well, I can write this as y to the 9 times y squared. 2 plus 9 is 11, so this works. And the reason I broke it down this way is because I want to find the largest number here, the largest exponent that's divisible by 3. Here I wanted to find the largest exponent was divisible by 2, because the index was 2. Here I want to find the largest exponent that's divisible by 3, and that's 9. So this is going to be the cubed root of y to the 9 times the cubed root of y squared. And when I do this, I divide, right? 9 divided by 3 is, y is just 3. And then this thing, nothing I can do about this. This is just the answer. When this number, when the index is larger than the exponent, you can't simplify it anymore. Because the way we're simplifying is by breaking it down. But if it's already smaller, you can't break it down anymore. All right, and then we can throw numbers and variables together. Okay, so let's do one of those. Let's do the square root of 96, r cubed. Let's do s to the 7. Okay, so I can break this down. I can write it as square root of 96, square root of r cubed, square root of s to the 7. So I really just have 3 individual problems, and so we know how to do this because we just did 3 examples. We just did examples that told us how to do these, right? But let's go through it. 96, I'm looking for the largest perfect square factor. Now, if you're quick at this, you'll see that it's 16. Right? 96 is 16 times 6. But I'll show you again how to get that. All right, so what I would do is I would take, well, I'll show you how I got that at the end. I don't want to clutter up the space here. So that's a perfect square factor, and it's the largest perfect square factor I can find. So that's how I want to break this down. Now let's go to the r cubed. Here I'm taking the square root, so I want to find the largest exponent that's less than 3 that's divisible by 2. So that's just 2. So this I'm going to write as r squared times r. And here I want to find the largest exponent that's less than 7 that's divisible by 2, which is 6. So that's s to the 6 times s. All right. So this is the square root of 16 times the square root of 6. The square root of r squared times r, square root of r. The square root of s to the 6 times the square root of s. Just using that property that I wrote down at the beginning. So square root of 16 is 4. Square root of r squared is r. And the square root of s to the 6th is, well, I divide, right? 6 divided by 2 is 3. It's s cubed. Now, what people usually do, and what you should do, is allocate all these variables in a standard way. So you put all the things that aren't in radicals off to the left. Put the numbers on the, well, there's 2 ways to write this now that I think about it. Let's do the thing I just said. Let's take all the things that aren't in radicals and put them on the left. So 4rs cubed. And now we can put all these radicals back together using that property in reverse. Right? So I can write this as just one big square root of 6rs. And that's how you should write your final answer. Okay. Now, let me go back to this 96. How did I break it down as 16 times 6? Well, 96 factors as 2 times, whenever it's even, I just divide by 2, right? So 2 times 48. 48 factors as 2 times 24. 24 factors as 2 times 12. Oops, I'm off the screen. 12 factors as 2 times 6. 6 factors as 2 times 3. All right, I'm looking for squares, so I'm looking for pairs of 2s. And I see 2 of them. See, whenever you have a pair, it's something squared. So that's what I'm looking for. So I have 2 squared and 2 squared. That's 4 times 4. Right, this is 4. This is 4. 4 times 4 is 16. That's how you get the 16. Right? In other words, you can write square root of 96 is 4 squared times what's left over is the 6, which is what we did. I wrote it as 16. Here I wrote it as 4 squared. Same thing. And then that's square root of 4 squared is 4, and square root of 6 you can't simplify. But that's my answer. Okay. So I'm going to break this down as cubed root of 80, cubed root x to the 17, cubed root of y to the 6. Okay. So Now I'm looking for a perfect cubed root, not perfect cubed root, a perfect cube factor of 80. And if you think about it, you should come up with 8. And if you need to make that tree to find it, that's totally fine. But 8 is a perfect cube. It's 2 cubed. So 8 times 10 is what we want to do here. Okay, so for the variable, I want to find the largest number less than 17 that's divisible by 3. Well, that's 15. So x to the 15, and then what's left over is x squared. The number that's left over should always be less than this number. If it's not, then you could have factored out something larger. What about this one? Well, this one is actually really nice because 6 is divisible by 3. So 6 divided by 3 is 2. This is just y squared. No radical part left over at all. It already is divisible by 3. So that's actually hunky-dory as it is. Okay. Here we have the cubed root of 8 times the cubed root of 8 times the cubed root of 10. Cubed root of 8 is 2, because 2 cubed is 8. And the cubed root of 10, nothing can be done there. Here we have the cubed root of x to the 15. Well, we divide 15 by 3. We get x to the 5 times the cubed root of x squared. This number is bigger than this number, so I can't simplify that anymore. And then the y squared. And now we collect all the terms that aren't under radicals on the left. So 2 x to the 5th, y squared. And I move all the other radicals on the right, and I combine them back together. So the cubed root of 10x squared. And so that's my final answer. So we're just looking for multiples of this number, really, as exponents. We can do a similar thing with fractions. So let me do a problem like that. So 150 r cubed divided by 256. Well, just like we had that property for multiplication, we also have a property for division. So this property right here, the root of a times b is root a times root b. Same thing for division, works exactly the same way. So the property there is root a over b, it could be any root, the nth root, is the nth root of a divided by the nth root of b. And that's really great. That means that we can do these roots separately, right? So I can write this as the square root of 150 r cubed divided by the square root of 256. And then we can use that other property for the top. We can write this as root 50 times root r cubed. So let's do that. It's root 150 times root r cubed divided by root 256. So we use both those properties. And now what do we do? Well, we're looking for a perfect square factor of 150. Thinking 25. 25 times 6 is 150. And 25 is the largest perfect square factor we can come up with. And like I said, you can do that tree thing to break it down and you'll find this. What about this guy? Well, I need to find the largest number less than 3 that's divisible by 2. Well, that's just 2. R squared times r. And in the bottom, who knows what the largest perfect square factor of 256 is? Well, it is 256. 256 is 16 squared, right? So this is just 16. Okay. It's a large number, but like I said, if you break it down like that tree, you'll see that's what you get. What happens here? This is root 25, which is 5 times root 6. Root r squared is r times root r divided by 16. Collect the non-radical terms on the left. So it's 5r root 6r divided by 16. You should also check on these to see if you can simplify this fraction. If 16 and 5 had common factors, we'd simplify this further and cancel those out. In this case, they don't, so I leave it like that. That's my final answer. Okay.